Having a backup generator on an off-grid solar power system has a lot of advantages. When you're not getting enough solar power, if you need a backup source of AC because of some problem in the solar power system, there's a lot of desirable reasons for having a generator for backup power. Something to consider when you're adding that for backup power to a system such as this, which has automatic controls, is that the inverters have now become automatic transfer switches. When the controller senses the batteries are low or you are commanding it to manually turn on, the inverters are automatically going to switch over when they sense the AC from the generator coming in. It's nice because from the inside of the house it's seamless, you never know what's happened, no interruption of power whatsoever. So you go on generator power. At the same time, in a normal system, the inverters are then consuming a lot of power in charging the batteries and in addition to supplying the house depending on how much you're using. So eventually when the batteries reach the full charge point, the inverters are going to turn the generator off. But prior to turning off the generator, they disconnect the AC feed from the generator. And then eventually they turn the generator off. Now this disconnection of AC feed from the generator can be a significant factor. And it's become significant if like us, you want to put the generator a good distance away from the house. And in this case, we're going to go 150 feet. The advantage being that the generator makes a certain amount of noise that you would really prefer to hear a minimum of in the house. We've got a little added advantage that even at 150 feet away, we've got a shed here that blocks the generator also. But remember that the power got interrupted over there at the house. And now we've got 150 feet of cable with high current electrical energy contained within it. And that energy is going to want to go somewhere, such as back into the generator. Now, us engineering types, we call this inductive kickback. You civilians probably call it a surge or something of that sort. And the result of this is that it induces a very high peak voltage back into the generator. And it's often felt that the generator probably has the ability to absorb that, and arguably up to a point the generator does. But let's look a bit at the internal construction of the generator, where your generator voltage is coming from. And that's this stator right here. And on this stator you see that the windings have a lacquer insulation on them, and where they pass through the stator they have these little plastic sleeves to insulate them from the stator. And all that's necessary because the stator is grounded and the voltages coming out of here are not grounded. Actually, there's a center tap on the stator and it's grounded, and then there's 120 volt feed of one phase, 120 volt feed of the other phase, and you can get 240 across both of those. But their center of that is grounded. And we'll discuss that in a whiteboard session later. Now, the suspicion that we have here is that over time, and in this case it took about 9 years or so, that those spikes can slowly wear at and degrade the insulation and ultimately result in a failure or short of the AC output to the stator, causing the generator to fail. So the solution becomes obvious: surge protection. And of course, we're all really very familiar with surge protection. However, in this case, you don't want to go to Home Depot or Best Buy for your surge protector. What you need is a real heavy-duty industrial grade surge protector like this little fuse. It's a dual SPD2-150M. And these are 150 volt industrial grade circuit breakers rated for 20 kiloamps of transient absorption. And this is actually sold in a pair. There's an extension on the part number. I'll give information on where I got this thing from DigiKey for about $125. So this surge protector also needs to be added at the generator output line before it goes into the long line underground. So that way you're absorbing the energy before it gets into the generator. And you technical types resist the temptation to put it in the generator ahead of the breaker. You want the generator breaker to function into these in case the surge protector should short out. Note there's also a life indicator on these surge protectors. These two little green windows will turn red in the event that the life of the protector has ended. So that takes care of all the surge protection issues. And the final issue, we go back 100 feet back to the solar power setup, will have to do with the auto start of the generator. We're going to be doing a whiteboard session shortly here to further explain schematically a lot of these technical details. But a lot of this does revolve around the fact that remote generator is automatically controlled. And automatic generator starts have some certain considerations that we're going to talk about. But I just wanted to show, this is the generator start control module, which is part of a three-part system that is part of Magnum's system for use with their inverters. If you're using any other brands or type of equipment, there's a whole bunch of generator auto start control modules out there and different systems, and you're gonna have to refer to your own instructions on how to install those. But I'll talk a little bit more about the specifics on my system when we get to the whiteboard session. Looking schematically at what I did for the generator, let's start over with that stator that we looked at. It has the big metal frame that's grounded, and off of that stator we have the windings that generate a total of 240 volts, which is split in to 120 volts. This is part of the reason I had to use two overvoltage arresters, because there's a center tap there to give you the 220 volt feeds, and that center tap is also grounded to the generator frame. So when you come out of the generator after the breaker, you need two separate overvoltage arresters to completely absorb all of the transients. If you only had it between the 240 volt rails, you're not completely catching the transients to ground. So then the generator feeds through the 150 feet of cable, and that's only a 240 volt feed. In my case, I'm only using 240. At the far end, I have a transformer that converts everything back to 120, because everything in my place is 120. I have no use for 240. So the other thing to bring up here is how this is related to and ties into the generator auto start, because after the breaker on the 120 volt side at the house, I have a little relay. Now when we look at generator auto starts, the setup like I've got has a signal for preheat for the diesel generator that runs for a few seconds. Then it has the start command that does like 3 starts, and if the 3 starts don't catch it, it faults out. And then you get a run signal back from the generator, which actually is related to oil pressure and temperature. The generator will shut itself off for oil pressure or temperature. So this run signal, which is based on that, comes back to the generator auto start to indicate that the generator has stopped. However, the one scenario that it doesn't include is whether or not the AC power drops out, because I need the system to shut the generator down when the power stops at the house, because there's things that can happen in between the generator and the house that can lose that power. So I got a little relay powered off the 120, the generator run signal comes into it, and it comes back out to go into the generator auto start, so that it shuts the generator down if we lose the power. And then the last signal from the auto start is the stop signal. And I'm indicating here my little buffer box and how each one of these control lines at the far end by the generator only activates a relay. Its signal really goes no further, because with the 150 foot feed, when I tried to tie these signals directly into these preheat start and run nodes within the generator, I had really odd behavior, which I had to attribute to there being actually too much current in these lines, over 150 feet on a small cable. So I built my little buffer box, which basically puts a relay in between every one of these lines. I'll include information on Kubota generators because there's at least one supplier of Kubota generators that actually adds a module inside the generator that greatly simplifies the installation of auto start over what I've done here. But this is what I did in my time. So that's the system looking at the generator electrically.